in the clustering rather than using their algorithm.
Aaron, take it away.
All right. Great. I'm for those who weren't here earlier on today, I'm Aaron Toombs. I'm a data journalist slash photojournalist slash general reporter slash basically web designer slash everything for our little newsroom Livewire Calgary here in Calgary. So today we're going to talk about R. So R is a language. It's a programming language. Not going to get into too much about what different programming languages are, but we will jump into my slides. So really what I want you to walk away with is not necessarily I'm going to go and be able to program in R at the very end of this. I cannot teach you to program in 45 minutes, but I can give you a taste about why programming.
Share your screen.
Oh, is it shared?
Yeah,
Oh.
share your screen at the bottom there, so
Okay.
we can record it.
Oh, yes. Tell how often I like to use. There we go.
There we go. Now we're in business.
Okay. So programming is a path to making your data more efficient, effective, and consistent. So you can create a script in R and have it work on the same type of data over and over and over and over and over again. You can play with data inside of R in a way that doesn't require you, like in the last session, to go undo. You can actually make real-time changes in your data and come up with different things. And you can do amazingly complex things in R that you simply cannot do in any other type of any type of setting outside of using another programming language. So there are a number of languages that exist for data journalism. Obviously, Python is a gigantic one. A lot of people use that. It's great. R is the one I prefer. MATLAB, which has been around for an extremely long time, sort of in the same vein as R, written sort of by mathematicians rather than programmers. And SQL. Now, SQL is more like a family of different languages as opposed to a single language itself. But if you're going to work in data journalism, chances are at one point you're going to use SQL. Why R? It's easy to use syntax. It's so much easier than other programming languages, especially if you're using something like C or C++. My goodness, what a difference. It's a relatively simple linear workflow. So you write code, you work through your data, you get an output at the end there. It doesn't require you to think on an object-oriented level where you're creating objects and you're going back and forth in your code, you're working between different files. It is much simpler than other languages. There are many, and I can't even stress this, not many different existing libraries written by extremely smart people who have PhDs, that solve virtually every single problem you will ever encounter in data science already. Why write yourself what somebody else did better? And there's lots of resources out there. You can go to places like DataCamp and learn how to use R from a extremely low level, like I'm going to learn how to actually do the syntax, all the way into super complex stuff. Like I want to write an entire geospatial suite on a particular type of data. They'll teach you how to do that. Other resources as well. If you ever take a stats class at a university, they'll likely teach you some kind of R. If you take any kind of economics class, every single economics professor I know writes in R. It is sort of default for what that side of how academics work. So there's a lot of resources there. So what we're going to use today is we're going to use RStudio Desktop. It's what's called an IDE, a integrated development environment. And that's where we're going to do all our programming in and give us a little bit of a GUI as well. GUI is graphical user interface to examine data. We're going to use something called a tidyverse library. It's a guy named Haley Wickham has written a ton of different stuff in R that really allows us to work with data in really interesting and easy ways. Again, why reinvent the wheel? Somebody already invented it. And we're going to use a custom data set based on some City of Calgary data today, because here we are. If you want to know where to get the data, I have a GitHub up there with a demo. You can download both the GeoJSON file and the CSV. And of course, there's how to install R right here as well. You just go right through that instructions, and it's fairly easy to do that. But let's jump into it. This is what R looks like. So,
Are you sure we're not seeing it on here?
oh, it's probably not sharing that screen. Let's share that one. that showing now? Okay, great. So this is what R looks like. It is very different than pretty much everything we've seen today. It is not like Excel. We are not looking at data directly. We are looking at all the commands that we are sending to the R language itself in order to interpret the data as it comes through. And as an example of what it is eventually going to do once I walk you through it, is it's going to create this sort of preliminary chart here. This sort of gives you an idea about some townhouse data here in Calgary. So definitely not a final product, but it gives you probably 95% of the way there that you then would take the data, throw it into something like Data Wrapper, make it nice and pretty, and then have something for the web. So we'll start a new file here. So one of the very first things we're going to do is we're going to install Tidyverse. And R is great because it has a repository called CRAN. And what this is really a curated set of libraries that are basically approved by the community to be stable and ready for use. So there's nothing really developmental about this at all. These are production ready libraries that you can basically use right now and use consistently and reliably. So that's really one great thing about R. You're not really having to mess around with something that people say may or may not work. And really to install, we would just literally go Tidyverse like there and press install. Now I already have it on my computer, so I'm not going to do that, but that's literally what you have to do. It's really that simple. And then once we load it in,
Does it tell you where to put it, where to store it on your hard drive?
it's going to take care of all the details for you. So when you install R for the very first time, it's going to create a bunch of directories for you on your computer. R is going to take care of where all the libraries are going to go. It's going to take care of all the details for you. So as long as you have hard drive space available there, you don't have to go and map variables in Windows or do variable mapping in Macintosh to do it. It's going to take care of all the details for you. So again, another reason why actually R is really great for first-time programmers is it takes care of the details. And so we're gonna call that library. And what that's going to do, and we're going to clear my cache here. So what it's going to do is when we run it, and if you see me running, what I'm doing is I'm pressing Command Shift Return on Mac. There's a little run button on here as well that you can use to run it. There's a variety of different ways to run your script. So basically, you're going to say to the IDE, please run my code. It's going to do that, and you're going to see in the console right here, it's going to give me a little bit of a warning right here saying what version number it's built under. When you get much more in depth into programming, versioning might be important. So it's going to give you some details there, but don't worry about it today. That warning is not important. And it's coming saying this is actually loaded. So now I have all my Tidyverse stuff loaded in, and I can use that entire package series to do a whole bunch of stuff. And we want to go and want to load some data up. So I've got a residential buildings permit CSV right here. And this is actually based on a much larger CSV. The residential permits in Calgary here is like 80,000 different ones. This has been cut down to make it a little bit smaller and a little easier to work with. So if you want to go through the demo afterwards as well, it'll make it a little bit easier for you folks. So the nice thing about this is we can literally just copy paste if we want. Tidyverse, this is part of Tidyverse. So this actual GUI that we're looking at right here in order to load in CSV files is built into it. And you can see that these dates have already been loaded into a format we can work with. So it's already taking a look at the data coming in and it's saying, okay, this is a date format. We're going to automatically format that into what R calls a date time object so that we can apply a whole bunch of functions to work with date times. It's going to go through and going to tell us a whole bunch of different things so that we don't necessarily have to do that. If we, for whatever reason, did want to change that, we can actually have it change from guess into all these different types of variable types as well. So there's a ton of ways of importing data that way right off the top. So we're just going to copy and paste that. We're going to throw that in just like that. We're going to run that again. And what we're going to end up with is this data set with 63,641 variables over 30 lines. So it looks just like this. And so you can see all these different types of, all these different type columns right across here. We've got geospatial data inside there. We've got well-known text data, which is slightly different than geospatial data. If you ever use something like QGIS or ArcGIS, it's going to be a little bit different the way it loads that. We've got addresses, we've got location types, we've got lat long already built into it here. So you can see the City of Calgary gives us tons of data, but then we're also got things that if you took the last session, we'll teach you how to clean up stuff as well.
Why does it have JSON format in there as well? There's one column in JSON format.
It's so the City of Calgary, as part of the open data, really tries to make things accessible. They kind of know that there's various ways of approaching a problem in different ways.
Right.
And they have a variety of different, like, they don't expect you to use ArcGIS. They don't expect you to use certain types of ESRI type programs. They give you a bunch of different options. That comes from feedback from the public. So the one thing I really like about the City of Calgary is they do try to give you a variety of different data types. And that's good for us, because that means we get to work with things in different ways, and whatever we want to work with to make our lives easier, we can do that.
So does that mean that everything that we would need would be in that one JSON column?
Yeah, so we don't need to load anything else for that. I'm going to show you how to merge things in this, because we might have to do that, but in this particular case, it's.
I just mentioned that because when you're downloading data, you will come across something like a JSON format or something like that.
Yeah.
It's just good to understand what that means, so you can ignore it.
Yeah.
If you
And probably further to point David's point here, like when you get into the programming side of things, you're kind of going to have to learn how formats work a lot more than you would otherwise. Like again with R, there's a bunch of packages that say that I want to load in a JSON file, and it'll do a bunch of things for us, and I'll show you how that kind of works here in a second. But understanding the underlying format of how data works is going to make your life a lot easier. And I'd say that in general, actually, just any kind of thing. So really what we want to look at is we want to look at, say, apartments or townhouses. Townhouses being a major issue here in Calgary. Kind of want to drill down on that. So what I'm going to do is I'm going to go to the console here. And one great thing about this is we can go resident. So it's going to pull up that data frame right there. We can go like that. We can go to, let's take a look at the permit type mapped. And so what that unique does is I'm going to say, I want to know what the unique types of every single value in that column are. So we know that there are 63,000 different items in that. We know it's probably not going to be 63,000 different types. We know it's probably going to be maybe 4 or 5 different types of buildings within that. And we want to know exactly how those are classified by the City of Calgary. So we can run that in our column, in our console, just by pressing enter. And so we have buildings and demolitions. Well, that's a good thing. We're going to do a function on this residential permits. We're going to make a brand new variable, just like that. We're going to take that existing variable that contains all that data, so that object that contains all the table. And this is where tidyverse is really interesting, and this makes it a little bit different than other programming languages. We are going to do something called pipe data. So what we're going to do is we're going to say, we want to take data outside of that residential building permits data frame, and we want to pipe that into a function. We want to take a certain part of that and work with that data set. And that means rather than writing a whole super long bit of code to individually work with bits, we can just work with that entire data set at one time. And this is one of the major advantages of using R. And we want to filter. We want to go to that permit type mount. Get rid of that S. S, by the way, is the sort of nomenclature that we use to actually call a variable, or in this case, those variables are the column names. If we were to run it with in front there, it would actually throw an error. But as a quick and handy way to actually get to our data column, we can use that and then just delete it afterwards. We can go equals. And again, we're going to be using direct logical functions in this. So if greater than, less than, equal, and for and question, or not question mark, exclamation mark for XOR. So if you haven't got up on your logic, probably since university, might want to do a little bit of that.
Did you mention or?
Or two, yeah.
And by the way, we are recording this. So I noticed that you got closer to the screen,
Yeah.
which is fine. But we are recording this and they will be posted. So just, take notes, but
Yeah.
it's all gonna be there.
Yeah, and as well, when you go back, the actual, like the original script that I wrote here, so if you want to see how I originally wrote this, that's available on my GitHub. You can go back and take a look at that entire code and work with it to your heart's content. So that's totally available for you to play with. So let's go with building. So we don't want to look at demolitions, we just want to look at buildings. We're going to run that again. And that's going to give us a second sort of set of a table here with the demolitions removed. And then one thing I'm always doing in R is I don't want to overwrite our original data load. So I want to really refine down on the table where they want to. And so much like the last presentation where we're sort of refining and changing and not making anything permanent here, really we're not trying to overwrite anything we've done before so that we can manipulate it and change it down the road afterwards. Okay, so we've got that. And then we're going to go look at unique again. And part of this is a little bit of data exploration too. Like this shows you how easy it is to actually do a little bit of data exploration if this is the first time you've ever looked at a data set. Okay, so I think we get permit type. Yeah, so we've got some permits right here, and we can also look at some of the other type, and we're gonna see which type of data actually works best for what we want to do. So we want to go turbine mount. So we can take a look through this, and we can actually take a look at all the various types of unique data. Okay. So what we have right here is basically all the City of Calgary permit code types. And if you notice inside this particular code, we actually have some duplications. So something, if you were cleaning up the data beforehand, you'd be able to sort of merge them into one data type. In this case right here, we'll work around that in a bit of an R way. This is where we can sort of use a little bit of regex. Regex is not as hard as people think it is. It is actually a lot easier than you think. It's sort of thinking about how do I break out a string of characters into its components. So I want to search for one part, or even regex can be as simple as I want to put a word into a string and then just like pull out true or false. So I want a string detect. And this is where I'm going to pull that permit class in this function. I'm going to say what I want to check for is 1606, because that is the townhouse there. And we'll just run that. Oh. And I've got those backed up. That's fine. Run that again. All right, so now we can basically find that we have 1,945 townhouses out of the entire set of data. So rather than going through and filtering a whole bunch of stuff, we did that basically programmatically in 9 lines? 9 lines of code right there. And then say we wanted to take a look at some other things. Say we wanted to filter all the townhouses on this list that had an application date of this year. So we wanted to look at the townhouse building applications for 2025 only. Well, we can go filter, where applied date is greater than or equal to. And this is where we can turn a text string into a date by using a function. So 25/01/01. And there we go. We actually now have every single townhouse project in the city of Calgary that was applied for this year. And then we can start doing some wonderful, interesting things with that. What a different library. This library is called SF. It's a spatial function library. So this is where we get to do really interesting things that even if you're not someone who works with maps on a regular basis, someone who doesn't like to use ArcGIS or QGIS, because those are hugely intimidating programs, we can actually use R in a way to work with geospatial data that is probably closer to what it looks like when you're using Excel, and still get functions that allow you to create great maps out of it. So FS is one of those really well-written libraries that'll deal with a lot of those issues for you. And we're going to run that and load it. And you can see we're going to get a few different errors and things. We're going to get some data, and that's just because it's going to be loading up and telling us that some of the things we're going to be doing in SF might overlap potentially with things that are in Tidyverse. The one thing about when you're doing any kind of programming language, whether it's R, whether it's Python, there's an issue called namespaces, and functions might have the same name between different packages. In this case, it's just telling us we have a few there. But very much like the reading the data there, we can go Calgary Geo. We're going to go back to folder there, GeoJSON. We're going to put a directory in and go Calgary communities 2025.geojson. Run that. Oh, I gotta. This is where we all discover just how bad of a speller I am. Maybe installing SF again. Where the joys of programming is occasionally things just stop working and you got to figure out why. Yeah. And part of my problem too is like I work between Windows and Mac. Like my Windows machine is my main computer I work on a regular basis. And so I have multi-monitors, I'm doing a lot of programming, and I have a ton of RAM and stuff. So I can, you know, if I'm going to work with something like a gigantic municipal data set, like I'm going to look at 20 years worth of tax data. I mean, that's probably about 10 gigabytes worth of data. And you can do that in R in a way that you can't do with anything else because it's designed to work with that. But sometimes things don't work.
Oh, yeah.
Oh, lovely. All right, we're going to try that again. There we go. Yeah, sometimes it can be really frustrating depending on the way that it wants to load things.
How do we know that it's working?
So if it fails like really badly, you will know. It will
But
just
there's nothing telling you that it's running right now.
so right now it's running fine.
Okay.
As long as the console's running, as long as when I press run and we see something in the console, we're okay. If we get errors, it'll tell us errors.
Okay.
When R crashes, it crashes badly. You're gonna get a big window that pops up with a big bomb logo there that basically says it all went wrong. So you don't have to work. Yeah, you will know when it's like, okay, I need to restart my computer. And trust me, as someone who used to do programming in C++, all those type of languages there, that is way friendlier than like suddenly you have no idea why your computer's not responding at all. So yeah, and just keep in mind, like you're never going to damage your computer with R. It's very self-contained. It's in a sandbox. It's not like other programming languages which are diving directly into like cores and kernels and things like that. So don't be afraid. Chances are if it blows up in your face, it's because it ran out of memory. All right, so that GeoJSON, if we want to plot it, geo, and this is going to take its sweet time, I think. Yeah. So we can sort of see this is what the geographical data works like on different levels here. So we've got all the different variables inside the GeoJSON, and we can actually take a look and see within that. And that GeoJSON right there, all that graphical, that geospatial data now becomes essentially a Excel worksheet. So we can actually work with that in the same way we would any kind of Excel thing. So you don't actually have
So you've used it to parse all the data within the GeoJSON column.
exactly. So we don't have to go and actually like go into QGIS or ArcGIS and like individually work with individual pieces and stuff. We can actually just work with it like we would any other piece of code.
So for this, in this data set, they put all the geographical information in GeoJSON.
Yeah. So yeah, we're looking right here. The geometry column right here is the one that contains all the actual polygon data that will show up in the map. But all the other extra sort of data that goes into it, like when that community was created, when it was modified, you know, the name of the community, all that good stuff there. That's all there.
And again, just to help folks understand, why did they do that? Why did they put the geographic information in the GeoJSON format?
Oh, so it doesn't actually. So if you were to look at that GeoJSON here, let me, that particular GeoJSON file, let's take a look here. We'll open it up. This is what that GeoJSON file looks like.
Yeah.
So
that's nasty.
That is not something you want to play around with outside of a programming language in any shape or form. So you can see why R turning it into this makes way more sense.
So they just do it just to keep it cleaner.
Well, it is machine readable. So when we're talking about GeoJSON, it's a machine readable format.
Yeah.
So it's designed for a computer to talk to a computer. It's not designed for a human being to sort of get in the way and take a look at that things. So what we're doing is we're using programming to turn a machine talking to a machine into a way for us to work with that data. And so what I really want to do is we want to go by COM. We're going to go like this. We're going to take that. We want to combine all those townhouses by community. So we really want to figure out just where those townhouses are being built in Calgary by community. We might not necessarily, like we could go and take a look at the individual points in the city. We could plot that. You know, we could look at it by ward. We could look at different ways. In this case here, let's say for the sake of example, a councillor in Northeast Calgary has said, oh, they're building not enough townhouses and they're building too many townhouses in the downtown. Well, we all know that's not true, but here's a way that we could figure that. So we're going to go group by. So we're going to group all of those ones, and we're going to go by community name.
And that's SQL, isn't it? Group by is a SQL.
Very similar. Yeah. So in R, in Python, in SQL, when you start looking at programming languages, there's going to be a relatively similar type of function name between different languages. Programmers are exceptionally lazy people. And I'll say this, my partner is a programmer. Like you work with enough stuff over time, you want things to be pretty relatively the same. And you don't necessarily want things to change a super amount. Both because you need your code to work like over decades, but you also don't want to have to learn a bunch of different terminology for different things. So if you learn R, you're going to learn a little bit of SQL, you're going to learn a little bit of Python, and vice versa. So community name, community code. And this is where it gets kind of fun because we can then go summarize. Absolutely. Yeah. This is the great thing about a great IDE. We're going to go housing units because we know that townhouses are not just one house. It's a whole bunch of houses in one little complex.
It's summarized with an S.
Summarized with an S
Okay.
or Z, up to you.
Okay, all right.
It's
Just-
relatively
Just-
American and UK spelling. So
Okay.
there's a lot of people. I mean, it's a very international language, so generally that works. And we can just run that again. And so suddenly we have this townhouse.com. And housing unit. Oh, I'm going to go. We're going to call this a count housing. And we're going to go make that a sum of all the housing units per community. So that's a little more what we're looking for. So we've got our 60 communities here that have townhouses, and then we can actually see just exactly how many units were built by community here. And then take it one step farther. We can go to house community. We're going to take the variable again. We're going to, again, use that data pipe. We're going to left join, and this is again one of those SQL logical things that you're going to learn in everything else. And we're going to take that with our Calgary Geo. And we're going to go, because the names, we want to match up the variable names, and R doesn't know that community name in the one data table is the same as in the other one. So like in this, we have community name in Calgary Geo, our GeoJSON file. We've got name, and it doesn't know it's the same thing. So we're gonna tell it that. In R, every single, there's a special thing called a vector, and you'll hear in other languages called an array. There are arrays in R. It's a little bit different. Again, we're working with the languages done by mathematicians, not by necessarily computer programmers. So the nomenclature is slightly different and they work slightly differently. But every single array in R is always going to start with C. It's just the way it's been since like the 1980s. And we're going to go and tell it that our community name is equal to name. And we're going to run that. And I'm going to make sure I got it, and I did not get it right. And uppercase and lowercase does matter. And so now we have all of the various counts of housing, but then with all the geographical data that we had in the GeoJSON.
That is really cool.
So we now basically can do a whole bunch of stuff. We can say like, for example, we know that in Redstone, we have 141 units being built in that community. We also know that's a developing community. We also know that in Shawnee Slopes, they're building 80 brand new townhouses in 2025 there. We also know that's a little bit different because it's an established community that was built in the 1980s, 1990s. So we can start to build data stories around that to address where people do and don't want to know about things. And this is where it kind of gets back to what we were originally doing here. We're going to pipe that again into a company called ggplot. And ggplot is one of those really interesting built-in libraries into the part tidyverse that allows us to build a chart for literally everything. If you were here earlier for Data Wrapper and you thought that was powerful, that is not even close to as powerful as ggplot is. ggplot, you can do anything you want with it. And just for the sake of time, I'm going to copy and paste some stuff here. And we'll run that. And we're going to call that count housing. And we'll just copy. And then you can see, like, even myself, who does a lot of computer programming every single day, like this is the putting it in, making sure you got everything sort of correctly typed in. Or did you use the right format? Did you use the right thing? This is the way that real programming goes. It's not like typing it in and making it work 100% the first time.
Also, isn't it preventing a lot of errors? It says error, whereas if you go through a Google sheet and you do something wrong, that thing's gonna show it.
Yeah.
Like, there's not gonna be a big sign saying error.
No,
Just try and figure out what you want, but.
And that's a great point. Like the one thing about a programming language is like it's not user friendly, so it's going to tell you every single time it fails and exactly why it fails. Like in this particular one right here, like this failed because problem commuting the stat. Well, the stat is a part of the ggplot there that's telling it what kind of chart it wants to build. So go back to the original one here, and basically just to show you what it looks like, again, going back to the plots, that's exactly what it would show up doing right there. So it would show us in the Northeast right here. Obviously, we have a ton of brand new townhouses being built. And that hypothetical counselor said they were building too many townhouses in the inner city and the downtown core. Well, they're not, because you can see that it's basically zero. And the nice thing about this is we can literally then just take something like this. We could actually export that townhouses with spatial data that in my original one right here. We'll just run that again. This global environment, I should mention that I'm playing with right here. That's where all your variables are going to live. So all your data frames, all your individual variables. If you have something like just a variable with a one number in it, all the way to arrays, to lists, to name pairs, to what we call, these are called data frames. So like gigantic data frames. They all live in this global environment. So you can click on it and explore it and look at things in a bit of a graphical way. So it makes it slightly easier for you while you're programming. So again, same sort of deal right there, slightly different data set looking at, because the year is different. But we could then export that into a CSV, and we could throw that into a data wrapper, and we can make a really nice chart out of the data that we had in here, having looked at it, explored it, narrowed it down to some data exploration, did some cleaning up. And that's 33 lines of code. So we didn't have to spend a couple hours in a different data thing. We could actually just work right through it. If we wanted to change things, we can certainly change it. Like this year applied date right here, we could change things as much as we want. We can add new things, we can remove things. If we wanted to look at a completely different thing, let's go unique residential burning class. Maybe it turns out that townhouses aren't that interesting. Maybe it turns out that improvements to single family homes are the thing that we really want to look at. Okay, pop that in, rerun it. Boom, there we go. Now we know what the single family homes are. That's simple. That is not going to be easy to do in Excel just by changing that like I did right there. So that is the real power of using a programming language, especially R, to do data journalism. Really, my suggestion, now that you got sort of a taste of it, is you're gonna have to learn a little bit of syntax. And again, like I can't teach you the entire things of R in 45 minutes. There's probably a lot here that, like, oh my God, that function, how am I gonna remember that function down the road? I would suggest going to something like DataCamp. DataCamp does have some free classes in R to start off there. They always run like 90% off deals around Christmas. So you can actually, like, don't sign up today. like wait for the sales, just good advice there. And you can work through like they have an interactive environment where you can actually work through these problems. You can learn R in an interactive way. It looks basically like this, but in the web. You can go take other classes. There are tons of like take a night class from University of Calgary, take a night class from Harvard, like I did. They all offer these online. They'll go through basically the same sort of deal right here. You'll have the opportunity to learn the language in a way that we're really sort of like step by step into it. And it's not scary. Like R is so much easier than other languages. I promise you that.
So why is Python so popular, like, compared to,
Well, because I can sit down and write Python and actually write actual application software to run on Windows or Macintosh. And I can do things like machine learning in that particular language that is a lot harder to do in R. Like with R, you can do machine learning, but what it's going to do is it's actually going to side load Python in to load up things like LLMs and other types of language models. So yeah, like it's getting a little bit complex. In the computer programming language world, we have things that are called Turing complete. And Turing complete basically means that a language allows you to write anything that you want to. It's sort of a concept that difference, like there are certain computer languages like scripting languages that only allow you to do certain things. You can't actually do an entire software development cycle in that. R, you can do an entire software development cycle in it. So you could actually write actual programs in this. You can do basically everything you want in this. You could actually rewrite the language itself in R. This is really super duper computer nerdy stuff. Doesn't really matter for you guys. Some languages are better at doing that than others. Python, you can do a lot of things in Python when it comes to actually working with the actual OS or working with certain types of environments that you can't do quite as easily in this. And that's where it comes into working with like the LLMs and things like that. So that's why data scientists use Python for that particular thing as opposed to something like R. R is like, I have a 10 gigabyte file worth of data and I need to work with it in a way that I can actually do that on my laptop here. If I had a 10 gigabyte data file on Python, it probably wouldn't run on my laptop with that language. So that's getting into maybe some of those considerations that way. But, and again, Python is very complex. It's a great language. You can do a ton of great stuff with it. R is easier. But it also means that if you're not familiar with programming, it's going to be harder to do certain types of things. Like if you want to extend this language yourself, you're going to need to know a lot more about how to do certain types of things that are a lot harder than it would be if you took Python. So there was a step in learning curve there that probably 99.9% of people will never encounter.
well, what we talked about, because usually we like to do the last session with coding, and Aaron suggested R just because it was the most accessible. So
Yeah, like this particular piece of code right here would be probably 150 lines in Python, and it would be a little more obtuse in terms of the way the language works. And you'd have to know a little bit more about how programming languages work in general. Like you have to know more about loops and more things like that. You don't have to know anything about loops and for loops and while loops and logical stuff that way, or know anything about actually how to write functions, or, worry about how variables go into functions, and worry about strong typed variables. And like, if those words make no sense to you, and they probably don't, you don't need to know that to use R. If you're working with Python, you kind of do.
and that story about the townhouses and the council, did you end up doing that?
I did actually.
Yeah, you did, right?
Yeah.
Okay.
Yeah.
So what was the story?
Literally just counselors
Full of
complaining.
shit? Council was full of shit?
I mean, that's the way it always is.
If only we could write headlines like that.
They don't know what that is.
No.
Yeah. Questions, please. No, students, those are things.
But then can you save all of this, or do you have to do all over it every time?
No, I save it every single time. And I don't know if I have it on here or not. I probably do. I'm gonna save that. Projects. Calgary Stampede. Is that the one? Yep, that's the one I want. So here's a really good example of I use this every single year. I go to the Calgary Stampede canvas auction every single year, and I use this chart every single year to basically load up a bunch of, okay, and it's number 3. Okay. So load that. So literally every single year I use this exact same chart that I wrote, in 2021, to basically load up this Google sheet that has all the this Calgary Stampede canvas auction bids, to basically load them up into R right here, so that I can then throw it into a CSV, and then I will load up, I'll switch over to my other.
Are you saying it was canvas auction?
Yeah. Realize not everyone's from Calgary. I should explain that a little bit. In Calgary, every single year for the Calgary Stampede truck wagon races, they have something called a canvas auction. So a bunch of Calgary companies come in and they bid to have their advertisement on the truck wagon that happens during the Calgary Stampede. And in Calgary, specifically, this is a big deal that doesn't matter anywhere else because it is received common wisdom. And this is what I disprove every single year, but there's received common wisdom that this is like the bellwether for what the Calgary economy actually looks like. So when de Havilland comes down and they spend $200,000 on buying advertising for truck wagons, everyone's like, oh, the economy must be great. Every year I do a chart about this and kind of show that it's not actually true. And so we go to something like Livewire. So pretty good example of what I do on a daily basis, actually, where I will literally go and do the story, do some data and take some pictures and all that fun stuff. But I mean, this is a chart that I've been working on year over year over year over year. And that's basically designed with my R code there. So literally I just go to the spreadsheet as they bids come in, I put them in my spreadsheet, I run my R code, boom, goes over a data wrapper here, builds this, I embed it into story and I'm done. And so rather than spending like hours and hours and hours every single year doing the exact same thing over and over again, it's already built. I press the run button and it's done. Another good example is every single day I do total measles cases in Alberta. So people want to know how many measles cases are happening in the province. I have a whole R script set up to do that, to pull that data from Alberta Health, to save those pages every single day because they update every single day. They don't give you historical data. And then it builds a chart and builds me my total measles cases thing. So it's basically automated to do that every single day. And that's what you can do in a programming language that you can't do in Excel. Yes.
So your workflow is download data, throw it into R, clean it, and then like export it as a CSV file with the data wrapper. It's good to go.
Yeah, and there is a thing called data wrap R, and it is an API that allows you to put data directly into data wrapper. It's kind of a pain in the ass to use, and like if you're familiar with sort of like internet data security, there's something called OAuth token, and it's sort of like a super long key that you basically have to use to say to that piece of software, I'm an authentic user, I'm not trying to hack your site, this is my data, I need you to put it into my thing. I just like putting CSVs in. It's just easier. For a one-off chart like I'm doing once per year, like for example, like Robson, who did his presentation earlier today, and what I did during COVID as well, is we both had scripts that would automatically put our stuff into Data Wrapper every single day through that API. And so it's a little more complex and stuff, but for one-off stuff, take that CSV, pop it in, done.
How many readers does your publication have?
About 1 million every year.
Who owns it?
Darren Krause. So if people don't know Darren Krause, he's the former editor of Metro Calgary. And when Metro laid him off, when they basically decided to be part of Torstar and rebrand, he was like, no, I'm gonna start my own publication. And yeah, so that's what he did. Been around for 8 years now.
And it's behind the paywall?
No, it's totally free. Yeah, everything we have is free. It's advertiser supported. It's Patreon supported.
Wow.
Every person in Calgary who donates to us is directly donating to making information free and accessible to Calgarians.
Wow. And it's obviously doing well.
We're doing okay.
Good.
We always have more money, but who doesn't want more money?
Good. That's good to see. And because it's an online publication, the fact that you can do stuff like this
Yep.
is way more. And that's what I stress to my students, is that chances are you're gonna be working for an online publication, probably behind the paywall, but if not, you're gonna be expected to do all of this stuff, so that when we advertise for people, like we always do, these are the kind of skills that we're looking for. And JS can attest to the same thing, right? These are the skills that are, and my big bugaboo is that not enough J schools these are the kind of courses that they are ditching, you know, and it's just, it is criminal, it makes no sense, it just, it drives me crazy, but.
Yeah, I
I
think
think
we're,
it's crazy that you have to do like night school, like.
Yep.
when you're-
No, absolutely.
when you're not interested.
Absolutely, no, yeah,
But I think J schools are trying to, or they like to find they're aligned with the market and they talk to employers and have an advisory committee with employers. The problem is that they're looking at their current needs. Knowing full well that in the next 10, 15 years, we will have lost our current listeners and viewers for traditional TV and radio.
Yeah.
And we will be way behind the pure players, and that has been an issue.
Yeah.
Like, we're playing catch up instead of saying, hey, let's develop those skills now.
Yeah.
So I do teach both Carleton U of O data storytelling skills to our students. The problem is that 1 in 100 will actually use them once they get a job, because the CBC, Press Canada, traditional print media and whatnot, even if they have a website, for the most part, don't want to invest the resources required to do data storytelling. They don't see the immediate benefit, at least that's it from my standpoint. So we teach it sometimes, but there is no direct correlation.
The upside-
to what they
Stuff like
think
that,
it
it's
is.
so visual, and like, I work at the Canada CBC Calgary, we talk about visual cases all the time, but there's no timeline that's visual, and it's like, there's just nothing of.
No, I did it manually in Ottawa during
And like,
COVID.
this is like, boom, you see it, like, it's out of control.
yeah.
In 1 second.
Yeah.
Great job.
So the good news about this is that this is a good investment for people to make in your time, and you just decide that you want to do this, you come to sessions like this, you go to data camps, you go to conferences like we all did, and we learned on our own. And, you know, when I was going through this, I didn't learn this stuff in J school.
Yeah.
You know, I didn't learn this at the CBC, and after that, I went to conferences like this and talk to people like this guy and this guy, and, you know, you form a community and you work because you see the advantage, right?
Honestly, you guys made such a good job at making it, accessible and not look like, I tried to do it on my own, like starting, and it's great, but also it looks like an elephant when you deep dive into like all the resources and stuff, and you're just like, this is out of control, I don't know where to start, I don't know. And then it's like, I got demotivated, and then I look at this and I'm like, okay, I'm just gonna start with small bites, and then it doesn't sound as scary anymore.
Like
Start small, and then as you get bigger, you'll realize you need slightly more sophisticated tools,
Exactly.
right? That's,
I like to know.
start small.
Yeah, I mean, like a perfect example is like my own journey. Like I did 2 years of computer science in 2004. And I left that because I didn't like doing calculus. And I didn't really like doing programming. And I didn't program again until 2015. And by that time, I already gone to J school. I was a photographer, like I was a photojournalist. I wasn't literally an award-winning sports and news photojournalist. Nobody would have said, Aaron Toombs, that's the guy I want to talk to R about. It just wouldn't have happened.
So how have things evolved?
I think it's about, I got bored in my career. Like storytelling is about having the right tool for the job, right? And data is the right tool for some of these things. I think Val this morning, when she was showing off her video about data science, about people, really. I mean, she had a great thing where it's so visual because she has a person from, you know, the public schools talking about she's an immigrant, she's talking about her own experience there, and then you throw the data inside and it adds to that. I mean, the guy behind the camera is making that as an experienced person that does the visual side so well. They have data people there. Like these are all things that come together into a package to make things better. And I realized in my career, I've always generally worked for indies. I worked for the Calgary Herald very, very briefly before I got laid off during the Sun Herald newsroom join. That if you want to have an interesting career, you got to have all these different tools to tell it different ways.
Yeah, go ahead.
Yeah.
No, but like, there's so much to story, like my strength is talking to people. I think I'm a good interviewer, but when you add to that the data, you don't have to necessarily show like tables and stuff like that, but it just makes the story more accountable because you start from what Val is doing and what a lot of people are doing is you start from the story of one person and then you make it into like something that is there's accountability and you can get a place where it's not just one person.
Or you take your findings and you show it to that counselor who's full of shit. And you say, hey, what do you think about this? Oh, geez, well, you know, that's your story. That interaction, that's your story.
Perfect example of that is Sarah Palmer, who is an intern with us right now at Livewire. Calgary City Councilor put out a video over the weekend with a whole bunch of misinformation. He's electioneering ahead of the municipal election. And Sarah went through and she's got data here looking at actual information. Like city councilor says rents are on the rise and haven't got back down. Well, Sarah's got some data here. It has. I mean, councilor says that house prices haven't gone down. Well, no, that's not true. They have. So perfect example of way that we're using data at Livewire to address an issue where people are making claims and we're fact checking.
Go ahead.
Yeah, I mean, my advice would be to start small. I mean, I don't consider myself to be a data journalist per se. Unlike Valerie, I never had the luxury of getting multiple days or weeks to work on a project. But what we did at a local level, when I was a writer and producer, was to just try to get data to supplement the reporting we were doing anyway. Meaning, instead of doing actually data-driven journalism, we were trying to find data to supplement more traditional reporting. For example, I don't know, we were doing a story about graffiti. There are data sets created by the city of Ottawa with complaints pertaining to graffiti. Well, that was a good way of just, take half a day, go get data and create a chart to demonstrate, to highlight, which neighborhood or neighborhoods were more problematic. So it's not like full-fledged data journalism, but it is nonetheless a branch of data-driven storytelling. And that will allow you to develop your skills.
We're 5 minutes past the session time.
All right, thanks a lot, guys. So this will be recorded, and so thanks very much.